I'm extremely excited to be here. I'd like to thank the organizers for inviting me. It's great to see an old friend and to make some new ones. And I want to thank you all for coming and listening to me talk about one of my favorite topics, which is how we use new technology in order to understand a very old problem, the spread of nuclear weapons. The way I'm going to tell this story is by showing you 3 pictures taken from satellites to illustrate the new way that we go about studying the spread of nuclear weapons. Before I do that, I want to talk broadly about why the world is changing so dramatically when it comes to really everything we do, not just what I study. The example I always give is to think about how we used to share vacation photographs. Most of the people in this room are very young, so this is how your parents did it. This is how I had to do it when I was very young. If you think about it, first of all, to take a photograph, you had to have a camera, like that. A single-use object. It only does one thing, takes pictures. But back then, it wasn't a digital camera. So to take a picture, you literally made an analog recording of an image on an object, a roll of film. And you had to fill that roll of film. And then when you were done, you had to literally take the roll of film out of the camera and take it to be developed. Now, if you plan to share these vacation photographs, you had to remember to ask the people who are going to develop it to make copies. And a human being would physically develop your film into physical objects, right, photographs. Now, you might think you're going to remember the people and the places and the time forever. I am now old. I know that is untrue. You will forget. What you should do is turn the photograph over and on the back, write down all of the data. When it was taken, where it was taken, and who's in it. And if you wanted to share that photograph, you would have to put it in an envelope, put a stamp on it, write someone's address, and then give it to the post office, where another series of human beings would hand deliver it to someone. And then that person could open up the envelope, take out the picture, and you had shared a vacation photograph. However, that person only has one copy and they can't share it with anyone else. That's what it was like in the past. Today, think about your phone. Your phone does all of those things. It has a camera. It can take a video. It can take as many pictures or videos as you want. In theory, it's possible to fill up your phone, but that's very hard to do. It collects all the data, when it was taken, where it was taken. If you put it on Facebook, Facebook will identify the faces in the picture. And the phone immediately accesses the internet, so you can share this picture with everyone in the world. And people can then turn around and share your picture with everyone they know. And this is how things go viral. What has happened is that the cost of collecting, storing, and sharing information has fallen to almost nothing. So we had satellite imagery in the past, but it was not available to those of us on the outside. And the kind of satellite imagery we had was different from what we have today. And so it's that transformation driven by technology that I want to talk about. Because just as technology is changing how we share information and how we live, Akiyama Sensei mentioned, for example, contactless payments. Those changes are also changing how we study international security. So this is the first picture that I want to show you, the first story I want to tell you about how things are changing. This is a satellite image taken by a company called Planet in San Francisco, founded by 2 friends of mine. It is a picture of a location in North Korea called Sohae or Tongchang-ri. where North Korea tests the engines for its new missiles. In 2018, North Korea agreed to dismantle this facility after the Singapore summit with President Trump. But after those negotiations collapsed in Hanoi about a year later, North Korea put it back together. One way in which satellites are changing how we do analysis is how easy it is to ask a company to take a picture, how quickly they can take a picture, and how quickly you can just simply download a picture like that to your computer. 20 years ago, if you wanted a digital picture, they would send it to you on a CD in the mail. In this case, we knew that there were changes happening at Tongchang-ri, and we were very interested. So we asked Planet to take a picture. Planet took 2 pictures on this day, which is really quite a lot. And in one of those pictures, which they took while I was asleep, there was a large shipping container. So we asked them to take a picture one day. I went to bed. They took the picture while I was asleep. I woke up in California, and I just simply downloaded the picture to my computer and saw a shipping container. Now, the way you analyze satellite imagery is you look for patterns. You need to know what's normal and what's not normal. In this location, it's not normal for shipping containers to be at this location, because the only time there is anybody here is when they are going to test a new engine. Kim Jong-un had said he wouldn't test any new engines as part of the Singapore agreement. And so we realized that this was a sign that North Korea was about to break that commitment. We downloaded the image, we processed it, we wrote an analysis of it, and it was on CNN later that afternoon. A few days later, North Korea actually conducted an engine test here, and the day after that, they announced that they had done so. We think this is probably the first time that a non-governmental group successfully identified and announced a violation of a non-proliferation commitment before it happened. That wasn't possible when you had to wait for a CD to arrive in the mail with your picture. So that's one change that I wanted to talk about. The second change is, it's not just that our pictures get to us more quickly. It's that we have so many more pictures. Had a thought. What would happen if you put a cell phone in space to take pictures? Now, they don't use cell phones to take pictures, but they do build small satellites that are about this big. And the advantage of building small satellites, which take advantage of all the same electronics that your phone does, is that they can put many of them in orbit, hundreds of them. And if you have a constellation of hundreds of satellites, then you can do something very ambitious, which is you can take a picture of the Earth every day. Now, there are limitations. The pictures that they take every day are not as sharp as the picture you just saw. These large structures are inflatable domes of the kind that children play football or soccer in. I don't know if you see them. I have a 10-year-old. He plays soccer in one of these domes every weekend. It smells like the inside of a tennis shoe. We had the idea that maybe China was building new silos, underground launch facilities for their missile force. And we knew that when they built such facilities, they often put up one of these large inflatable domes and did the construction underneath it. And because they're large, you can see them even in a picture like this, where the resolution, the sharpness of the picture is 3 meters. And what that means is a pixel size is about 3 meters square. So hard to see a car, but you can definitely see a building. Right? Well, inflatable domes are very large. You can see them quite clearly. And Planet's taking a picture of the entire Earth almost every day. They don't always succeed because there are clouds and occasionally small gaps. But we knew we had a picture of all of China every month. Every month, a complete and full picture of China. And so we thought we could find any new construction. So I asked my colleague Decker Eveleth to design a search strategy. Where would China build new silos? And to look. And what would you look for? And he said, well, I'm going to look for these large inflatable structures. This would be impossible with high-resolution satellite imagery, because high-resolution pictures are close-ups. So they take a small, tiny picture, like a picture of a small area. But medium-resolution pictures like this, right, you can get a picture of the whole world. So we had a fresh picture of all of China. And we're getting a new one every month, every few weeks, actually. And so Decker went through all the areas where he thought China might build such underground launch sites and found a field of more than 100 of these inflatable structures, arrayed in a way that made it clear that this was a new silo field. Now, China really previously only had about 100 ICBMs that could strike the United States. So to see 100 new silos being constructed was an enormous find. And shortly after Decker found that, other people started looking, and other people found 2 more fields. This is one of the most dramatic changes that we have ever seen in a country's nuclear posture. And while I'm sure that some governments knew about it, it's also the first time that non-governmental experts were able to detect such a change on essentially the same timeline as the US government. Because we were getting the pictures at the same time they were, and all we had to do was look. This last picture is not from North Korea or China, it's from Russia. And it looks a little different than the other 2 pictures you saw, because it's not really a picture at all. This image is a computer-generated image that shows radar data. So a satellite in space sends microwaves to Earth. They strike the Earth and they bounce back. They're recorded, and the radar data can be represented as a picture. So you can see roads. The roads are black. The roads are not black because the pavement is black. The roads are black because they're smooth. And the microwave beams bounce off them. You see fields and trees, which are sort of gray and fuzzy. But they're not gray and fuzzy because leaves are kind of soft and small. They're fuzzy because leaves are all at different angles, so they reflect some of the microwaves, but not all. And then you see houses and military vehicles, which are bright white. And they're not bright white because that's the color they're painted, because they're green, but because they strongly reflect microwaves. So it's not really a picture, although it looks like one. It's really just data. It's data about how strongly these objects in the ground reflect microwaves, the time it took, which is the distance for the microwave to reach the ground and come back, and other similar kinds of numerical information. What's great about radar imagery is microwaves pass right through clouds. So I said Planet tries to take a picture of the Earth every day, but sometimes they can't get a picture because it's cloudy. It's always cloudy in Ukraine in February. We took many, many optical pictures of places like this, and all we saw were clouds. But the radar pictures were always clear. And in this particular case, what you're looking at is a Russian military unit the day before the war, the day before the invasion began. And what was notable to us about this unit is that all the vehicles, it's hard to see, but all the vehicles are lined up along roads in lines, which means that they're not parked in order to stay. It means they're waiting on the side of the road in order to invade Ukraine. It's hard to interpret an image like this. We had a little help. Someone drove by these military vehicles and recorded them with a phone and made a TikTok video and put it online. It's very strange, right? And so we were able to determine that this was a Russian military unit that was going to be one of the first ones to invade Ukraine. And we immediately called CNN and said, the invasion's going to start tomorrow. Here's the picture. Do you know what CNN said? We can't see it. So we were very disappointed. So we sat in our office feeling a little glum and wondering how we might see the invasion start. Then it occurred to us to look at Google Maps. Do you use Google Maps to get to school or to work? It tells you the traffic, right? Well, we were looking at Google Maps and we saw on this road right here, at 3 o'clock in the morning in Russia, a traffic jam. There usually aren't traffic jams at 3 o'clock in the morning. What was happening is the Russians were putting up roadblocks so that no one could drive. And we were able to use the traffic data in Google Maps to determine that this unit, which we had identified in a radar image, was on its way to Ukraine. And we watched them slowly move down the road all the way to the border. We announced the invasion was starting on Twitter. No one believed us. And then a few hours later, the bombs fell. These are 3 instances which I think really illustrate what I'm trying to tell you about what your phones mean. The lesson is that the cost of collecting and storing and sharing information now is almost 0. And that means that we can not only get all kinds of amazing pictures from space, whether they are high-resolution pictures taken at demand, whether they are low-resolution images of the whole Earth taken every day, or whether they are pictures that aren't even pictures at all, that are just radar. We can analyze those wherever we live, and we can tell the whole world about it immediately. And to me, that is an extremely exciting and unbelievable way to do the work that we have always wanted to do. Thank you.